I got slightly better copy. Managed to find that bad boy. This triangle, looking for the area of the shaded region, so I've just got 7 times 13 over 2. Punch that out real quick, 7 times 13 over 2. And that's going to give me 45.5. My next one, parallelogram, just 9 times 14. 90 plus 36, 126. And done there. This one, again, they're just looking for this height of the parallelogram, so we've got 17 times x, base times height, is equal to area. Divide the 17 off, x is going to be equal to 9, and I've got a feet in there. 528 is equal to base times height, so 33 times x. Divide that 33 off, 528 divided by 33 gives me a 16. X equals 16 centimeters. Number 13, I've got 399 is equal to 21x over 2. Make sure we remember because we've got a triangle over 2. That's going to give me 798 is equal to 21x. Pull that real quick, 798, 21. X is going to give me 38. This one, I've got a triangle and a rectangle I'm put together. The rectangle is easy, 10 times 6. The triangle also easy, 30 over 2. We've got base is 10, height is 3. Got to divide it by 2 because it's a triangle, so I'll get 75 there. And that one's going to be meters squared. This one, you may think parallelogram. What will be so much better? Trapezoid. We'll get 16 plus, what is that going to be, 23 over 2 times 9. That way you don't have to do multiple calculations. I'll go 16 plus 23 divided by 2 times 9, and then I will get 175.5 feet squared. Alright, so don't go crazy and go doing the trapezoid and then trying to calculate this little triangle, or the parallelogram, and then try to calculate this triangle. Treat it as a trapezoid, much easier. This one's another excellent example of don't get crazy, just do one thing. So we've got 41 on the bottom, 22 on the top, so 41 plus 22 over 2. Base 1, base 2 over 2 times height, which is 12. 41 plus 22 over 2 times 12. Boom. 378. And that one's going to be inches squared. Again, easy. Try to go easy on it. This is also 26. If we've got this base 26 and on a rectangle, this base will also be 26. This is a 13, 5, 12 triangle. So I'll have 24 times 10 over 2 for my triangle, and I'll have 14 times 26 for my rectangle. So 26 times 14 plus 12 times 10. Boom. 484 centimeters squared. Alright. Moving along. On this one, I've got 2, 2, 3, 6, 5, 6, 6, yeah, 5, 6, and then 4, 2. So I've got myself a little parallelogram here. Base is 2, height is 4, so my total area is going to be 8. This one, -4, -4, -1, -1, 5, -4. Got myself a handy little triangle. Base is going to be 9. Height is going to be 3. Watch that scale. And then over 2 is going to give me a 13.5. No units. You can throw on a unit squared if it makes you feel better about it. Find the height and area of the polygon. This is 12. Oh, my light's flashing. I got a little scared there for a second. This is 12. So square root of 2, 1 and 1. That's going to be 6 square roots of 2 here for my height. Base is 20. Height is 6 square roots of 2. So my total area, this is my height by the way, my total area is going to be 120 square roots of 2 inches squared. Boom. This one, got an 11 over here, so it should be over here. This is 60 degrees, 30 degrees, so this is on the 2 side. The 1 side will be 5.5, the square root of 3 side will be 5.5, square roots of 3. So I have a base of 17, I've got a height of 5.5 square roots of 3, so I'm going to go 17 times 5.5, and that's going to give me 93.5 square roots of 3, and that's going to be meters squared for my area. And then I've got this meters for my height. Moving along, I've got some kites, some rhombuses. If this is 10 and this is 6, I've got a first diagonal of 16. This diagonal is going to get bisected. So I've got 10 times 16. It's a kite, so we're going to have to divide that by 2. We'll say it's 80 units squared. Rhombus, got those corners, so rhombus, 16 times 14, or well, rather 32 times 14 over 2. Like doing that. There we go. Boom, boom, boom. 224. We'll say units squared just to keep up. Right here, you've got an area of 330, and they want to know how much x is. Well, 2x is going to be your diagonal. 30 is going to be your other diagonal. And if we divide diagonal by 2, then we get that area. 2's cancel, divide by 30, x is equal to 11 inches. Right here, I've got 21 plus 28 over 2, base 1, base 2, over 2, times height, which is unknown, equals 196. So the first thing I'm going to do is multiply by 2, and I will get, what is that, 49x is equal to some number, gracious, 392. So x is going to be equal to 392 over, I want to say it's 6, 392 over 49. 8, gracious, should have said 8. 8 feet. That's why you punch that calculator from time to time. Your brain power lessens as we continue. Correction, my brain power lessens. So I've got 6 plus 8, base 1, base 2, over 2 times height, which is 17. That's going to be equal to 180, I'm off paper, 187. What I'm going to do here is I'm going to multiply this by 2, divide it by 17, so I'll get 6 plus x is equal to 187 divided by 17 is 11 times 2 is 22. Subtract the 6, x is equal to 60, and that'll be centimeters. Looking pretty good. Now, on these, remember that you've got a one-dimensional ratio and you've got a two-dimensional ratio. So on this one, my one-dimensional ratio is 2 to 5. So my two-dimensional ratio is going to be 4 to 25. And now I just set it equal to my unknowns. So 2 is the area of my small one, x unknown for my big one, half of that, so half of this will be 12.5 feet squared. You can cross multiply solve, you get the same answer. If you want to, my one-dimensional answer here, one-dimensional ratio rather, 14 over 20. That's going to be 7 over 10. Still one-dimensional. I want that two-dimensional because I've got some areas to set up in a proportion. That'll be 49 to 100, squaring both of those. I'm going to set it equal to my proportion. I know my larger area is 400, so my smaller area will be across from my 49. This is times 4, so times 4, 196, and that's going to be inches squared. Again, you can cross multiply solve if you want to. It is the same answer. This one, they're going to start off with the area ratio, and then we're going to do our sides. So I have 135 over 15. This is my two-dimensional ratio. I'm going to reduce that. They're both divisible by 15. So still in my two-dimensional ratio, 9 to 1. I want to go to my one-dimensional ratio, so we're going to take the root of that, 3 over 1. And now I can set it up to my proportion of sides. So I have 15 over an unknown side for xy times 5 times 5. X is going to be 5, and this one is all in inches. My last one, I got to go back and do those real quick. But this is pretty fast. I've got 168 to 378, and they are both divisible by some 42. They're both divisible by 42. This is going to be 4, and I think that's a 9. 42. Yeah, I remember working this one. So still in that two-dimensional ratio. We're going to cut it here.